Hello, everyone. I am Suzanne DeFree, Group Event Director for Informa Markets Virtual Engineering Days, an all-new conference and expo for plastics, packaging, and manufacturing professionals, June 15th through 17th, 2021. And I'm happy to welcome Virtual Engineering Days keynoter, Robin Phillips, head of SpaceLab at Maxon. Robin has been an aerospace project manager with Maxon for 13 years. As head of the SpaceLab, Robin is in charge of Maxon's space activities, including Mars rover projects. Prior to Maxon, he worked as a scientist in Hawaii at the James Clerk Maxwell Telescope before moving on to project management for a remotely operated astronomical instrument. The mechanisms in the instrument require customized motors and gearboxes, which linked him to Maxon. Thanks for joining us today, Robin.
Thank you.
So Robin, Maxon has for several years partnered with NASA, providing electric drives and motors on some of its most ambitious missions, including the recent Mars rover Perseverance and the helicopter brought along for its first flight. Let's put aside the rovers for a moment, which are amazing in their own right, and let's talk about the helicopter. When it successfully completed its first power-controlled flight on a planet besides Earth, taking off vertically and just hovering for a few moments last month. It was one of the most incredible achievements I've seen in my 20 plus years of working with engineers. Can you overview Maxon's role in the helicopter?
Sure. So, I mean, I think for us as well, we sat there watching all those images coming back, and it was indeed a pretty amazing experience. I mean, I think for all of us working on the project, although the vast majority of our work on the science that's going to be returned is all in the rover and the mechanisms and motors we've provided that go into the rover, what's really caught everybody's imagination is this ability to do the first controlled, powered flight on another planet. And we were lucky enough there to have these small compact motors that were exactly what was needed to control the flight of the helicopter. So it's not the main drive motor that was done by the core JPL team that built the helicopter. They did that motor themselves. But what is needed is a very small motor, or a set of 6 of them, to control the swash plate. And a swash plate is something that every helicopter on Earth as well has, and it sets the angle of the propellers, if you like, or the angle of the rotor, to enable you to control whether the helicopter goes up, down, left, right, forwards, or back. So it's really controlling it. And what's really needed there is something that's as small and as lightweight as possible, because of course anyone who's been following this along knows that the big challenge was to make the whole system in this 1.8 kilograms, and you can just about make that lift off, and every gram counts. And so these motors, they're coming in at about 7 grams each, and 6 of them. You want 3 for each of the 2 propellers that are on there, and that's basically what we provided there. And every time that we see it fly, then we know it's our motors there doing the controlling. And in fact, you may have seen this just in the week before we recorded this. The 6th flight had a software problem that caused the helicopter sort of swing backwards and forwards a lot as it was flying. And the commands to make that swinging happen were of course coming from the onboard computer, but it was our motors that were having to perform that action. So they actually had to work much harder than normal. So we were very relieved to see that they passed that test as well.
It's incredible, to be honest. It really is incredible how everything is adapting up there. Outside of our planet generally. So Robin, what types of customizations had to be made to the existing motors and drive technology to be ready for Mars, which is a very harsh and unaccommodating environment for these systems that were developed on Earth?
Right. So since the helicopter is just a demonstration mission, there was no attempt here by NASA or JPL to fully develop new components for it. The idea was to always use something that already exists. So commercial off the shelf is sort of the buzz phrase. But if you consider what that means, I mean, Maxon is a company that primarily builds motors for industrial applications, medical applications, and things like that. So you have to think about what's different on Mars to a product that's been designed to be used in a hospital or to be used in a factory. And the answer really is You lift off on a rocket, so there's lots of vibrations there. There's staging as the rocket goes through its different separation stages. That puts big shocks on your payload. Then you have to survive the travel through vacuum for 6 to 9 months to get to Mars. Then you land on Mars, that's more shocks. And then once you're on Mars, you're exposed to the day-night temperature cycling. So that's sort of down to minus 130 degrees C at night, and back up to about freezing during the day. And operate, of course, in this very low density CO2 atmosphere. So those are sort of the environmental differences. So that means we have to make sure we use materials that don't outgas, so they're suitable for use in a vacuum. We have to pair the materials so that expansion coefficients, when we go very cold or very hot, don't cause it to fall apart. And we have to add robustness features so that the shocks that it experiences during this launch and landing don't cause the motor to fall apart. So those are sort of the main criteria that we're looking at.
Robin, you just mentioned that Maxon has a lot of motors that are in use in the industrial and medical spaces, which have their own no-fail type of requirements. But what were the no-fail requirements for high precision, long life motor in this type of project, and how do you really even plan for that?
Right. So, I mean, no fail means exactly that. There's this huge team of people all around the world who've put thousands and thousands of hours into designing and building these rovers and flying them to Mars. And these motors have absolutely critical applications. For the helicopter, as I just described, if we don't control the rotors properly, it crashes. Within the rover, the main mission, that of course is going to run for years, our motors have to handle every sample that it's collecting. And if the sample handling system doesn't work, it can't collect its samples. So the question is more, how do you fulfill that requirements? And we really do that by having a process. And that process is we take our industrial design, we consider theoretically what we need to change. So we make those design changes, then we build them, and then we test them. And we test them in exactly the same way that they're going to be flown. So we put them on a shock stand. Maxon has a whole laboratory full of these pieces of equipment that we need, and we shock them, and we confirm it doesn't fall apart. Then we have an environmental chamber or a vacuum chamber, and we put them in there, and we confirm it works under vacuum. Then we cool it down to minus 130. We do lots of cycles in our temperature chamber between minus 130 and plus 10, 20 to show it doesn't fall apart over this temperature range. And at the end, you can say, okay, now I know my design is good. And then all you have to do, in inverted commas, that's the difficult bit, is build the flight units exactly the same way as you built the test units. And so we have these skilled production engineers who document every step that they did for building the qualification units, and then they follow exactly those same processes again to build the flight units. And because I have a team who I have real trust in here, I was not as nervous as maybe many people thought, because we'd shown in advance that our design worked, and I knew I had people on the production line who were going to not make mistakes when they put this together. And because we know we have humans there, of course we have extra people checking the work, so because everybody naturally always makes mistakes, so you have to plan correctly for those mistakes to be made and for them to be caught. And that's part of our job in the Maxon SpaceLab, is to set up the process so that everybody can do their job correctly, and it looks like it worked.
Excellent, great. So Robin, I mentioned that you're presenting a keynote for us at Virtual Engineering Days. The title of that keynote is Motors in Space to Mars and Beyond. What's next? What's the beyond?
So science missions, of course, I think is what we've been known for the last sort of 20 years on Mars, from starting with Sojourner and going through Spirit and Opportunity, and now Perseverance, plus a number of others in between. But I think what's really being revolutionized, and we have to say that this is almost a one-man show through SpaceX and Elon Musk, is the cost of access to space. And they're in the process of reducing the cost of putting things in space, satellites around the Earth, by an order of magnitude. And whenever you do an order of magnitude cost reduction in an industry, it opens up new possibilities for commercial activity that weren't there before. And what beyond for Maxon really means being part of this commercialization of space. So Maxon's normal sales area is not just going to be hospitals, industrial facilities, things like that on Earth, but it's going to be satellites and these future applications that are going to be up there. And by preparing ourselves through the science missions and showing that we have the technology and the processes, then I think we're ready for beyond to go into commercial space.
Well, I think I've used the word incredible at least 5 times during our short conversation here, but I have no other word for it. It really is incredible what Maxon and all the engineers that have worked on the rovers and the helicopter have done. And what you're describing as a beyond, I can't wait to see that. It's just going to be incredible.
Right. Yes, I mean, there's a number of these new space missions underway at the moment, and we're very excited to be part of them.
Great. Well, thank you for joining us this morning, Robin. Be sure to register for Virtual Engineering Days at engineeringwk.com and hear more from Maxon's Robin Phillips in the opening keynote, Motors in Space to Mars and Beyond on June 15th at 11 a.m. Eastern. Thanks again, Robin.
Thank you.